Hey folks, today we're going to talk about scripting in Ansys SpaceClaim Direct Modeler. And so on the screen you see a Workbench project with a simple static structural system. And here is the CAD that is within that system. We're looking at a simple cylinder within SpaceClaim. And if you've used SpaceClaim before, you may now notice this additional window on the right with a bunch of coding in it. And this is the scripting feature that's available within SpaceClaim Direct Modeler. It is still only a beta feature. It's not been released as a fully validated feature, but the developers are heading that way with it. But having used it myself a little bit for production work, I would say that it's fairly robust and reliable. And it's also great for CAD iteration type design work. So if you want to try various what-if scenarios on your CAD, setting up the script with parameters and such is a great way to do that. So once I develop this script, I can then pass it over to Workbench Mechanical and run a scenario or a series of scenarios with it. So here we see the geometry input with a mesh and various name selections that we pulled in from the script, and our loading, and finally some result items. So what I'm going to do is pause here, and I'm going to dismantle the script and come back and show you how I constructed it to get to where we are here. Okay, so we've started our work and we've opened up SpaceClaim. And unless you've imported geometry on the project page, you're going to open up SpaceClaim to a blank screen like you see here. And by the way, scripting does not just apply to a ground zero type of scenario. In other words, we don't have to use scripting simply to build a model from scratch. We can use it to alter existing CAD if we'd like. But the video here is intended to give you some basic understanding of how to use the feature so you can then leverage that understanding and apply it to your scenario and your model. So once we have SpaceClaim opened up, the first thing we're going to want to do is come up here to File, New, Script. And you'll notice the beta memo here that I pointed out earlier. So let's go ahead and click that, and here's where we get the new window on the right to begin our scripting. Now let's begin talking about how to construct these scripts. And you may recall the script you saw a little bit ago, and it may have appeared a little intimidating. It is the Python language. Perhaps you don't know that language or the commands or the syntax. Quite frankly, I don't know it very well. But one very useful feature we have in SpaceClaim is this record option. So if we turn this on, we can begin to carry out a series of actions in the workspace to draw our model. Let's go ahead and do that and see what happens. I'm first going to select a sketch plane. On that plane, I'm going to draw a rectangle. We notice stuff occurring here over in the script editor. Let me switch to 3D mode, and I'm going to pull it into a block. Now let me double click to get an edge chain and pull it into rounds. Escape key to kill that pull command, and let me turn the recorder off. And so now we have several dozen lines of commands here that we probably previously didn't know how to construct from scratch. The recorder did it for us, and it provided a great starting point for us to be able to understand the syntax that created this block in the workspace. So one thing we might want to try first is to see what happens if we delete this solid from the structure tree and rerun our script with this button here. Look what happens. The block is recreated identically to what it was just a moment ago. And so although I may not understand the Python language very well, I can begin to look at this set of commands to understand the syntax that went into creating this block that we see in the workspace. And so if I begin to investigate, we can look here at this set of commands that created the initial rectangle. And I see some different numbers here in the commands. I might be inclined to change some of them and rerun the script to see what happens. I'll go ahead and delete the solid from the structure tree and rerun the script. We notice now that the block is shorter. Down here is the set of commands that created the pull of the rectangle into a solid body. And I notice some numbers here. I might be inclined again to see what happens if I change that number. I'll delete this solid from the tree and rerun the script. And we notice now that the block is longer in the X direction. So yes, changing that parameter affected the outcome. Let me hit Control Z in the script editor, which by the way, Control Z and Control Y work the same as they would anywhere else in the script editor for undo and redo operations. Let me go ahead and delete this solid to get back to the initial block we had. And so now you may be wondering, well geez, I should be able to create parameters for these numbers so I can run a parametric study. And you're right. So let's take a look at how we can do that. I'm going to come down here into the script editor and insert some arbitrary parameter names. The block height will be 50. The block extrusion length will be 100. Now let's come down into the syntax and change the numbers into those parameters. If we scroll down a little further, we can change the extrusion length. Now if we come over to the structure tree, we can right click and delete this solid. Now let's rerun the script and see what happens. We notice now that the block is shorter and the extrusion was longer, as we expected. But the parameters we created here might be better thought of as script variables because they're not really parameters in the classic sense that we might think we could pass over to Workbench for a parametric simulation. And we can prove that by coming over here to the Groups tab and noticing that there are no parameters listed. So these are merely variables in our script, and we need to talk about how to convert them into parameters so we can pass them to Workbench to run our parametric simulation. But we need to pause real quick and talk about one other quick thing. How do we save our work? We don't want to lose our work. Currently, the script is just kind of hanging in memory. It's not captured as part of the model that we're working on. So, if we come up here, we click this drop down and we have two different options. We can save the script to the hard disk, which means the script will need opened back up into our model every time we want to work on this model. Or we can use it on another model. The other option here is to save the script to a group. This option means it's going to be captured as part of this model permanently. So I'm going to select this first option, hit the Save button, and we notice over here now that we have a group saved in our Groups tab. So now the script has been captured as part of the model. So now let's get back to talking about how we can convert those script variables into parameters that are recognizable by Workbench for a parametric study. And it starts here in the Groups tab. So I want to right click and create a parameter. So we have parameter 1. We can right click and rename it. We'll call it block underscore height. Now I want to click on this 0, type a 1 and hit enter. I want to illustrate a point. So if we right click, we can take a look at the unit type. By default, it's at unitless. This actually means meter, and that's because the base unit of the SpaceClaim architecture upon which it's built is a meter. If we change it to length, it's going to convert to our active unit system, and in this case, we're using English units. And I can show you that here in the SpaceClaim options if we come to Units, Imperial. Let's change it to metric and see what happens. It now converts to 1,000 millimeters. Now we're going to reset it back to English because that's what we've been working in. Now I point out this subtle detail, this pitfall if you will, because it manifests itself again in the script in a little bit, and I'll show you how to deal with it. But first we need to create one more parameter. So we'll right click and rename it. We'll call it block underscore extrusion. And we'll set it at 1 also. We can change it later. We'll set the unit type as length. So now let's talk about how to incorporate these parameters into our script. I'm first going to start by right clicking on this group and pausing it, because as we begin working on these parameters, it's going to try an auto update, and I don't want that to take place right now. So let me go back to the top of my script. I'm going to delete the 50. It turns out that in this Python language, the parameters object is what's needed to pull this off. So we notice the smart autocomplete once we start typing. We can just double click the parameters object, period. The autocomplete brings available our two parameters now. So we can choose block height. If I delete the 100, I can do the same thing. Parameters dot block extrusion. Now let me come back to the Groups tab. I'll change the block height to 50. I'll change the block extrusion to 100. Let's come to the Structures tab and delete this block. And we're going to notice something interesting once I unpause this and run it. Clearly there's a problem with the block. And this is what I was trying to point out earlier when I said there's a tiny little pitfall when using English units. When the parameters are passed from the Groups tab to the script editor, they are passed as meters. So we need to come into the script editor and we need to incorporate the conversion factor of 39.37 when using English units. So now let's delete this solid, come to the Groups tab, and run the script. And this is the block that we expected. So be aware of that tiny detail when you're using units other than meters. You don't want to be trapped by that. Now let's segue back to the original model that we started with, the cylinder. A very similar workflow was used to construct the cylinder. In other words, I turned on the recorder in the script editor, and while sketching and modeling in the workspace, Python commands were captured in the script editor. Then afterwards, I went into the commands and altered their syntax to populate them with parameters to run my parametric simulation. And you notice in the Groups tab on the left, various parameters that are ready to go. If you're like me and don't know much about the Python language, there's a couple resources you can turn to. The first I'd point you to is to go to your Ansys installation directory, assuming you have a standard installation in C program files. If you come to this location, you can find this help file. Double click it and open it up. And you can find a whole slew of commands here for the Python language. And to my knowledge, this is not all-inclusive. However, there's many here to get you started. And one we used recently in the block model was constant round. So we can click on it and read about the syntax and how the command operates. Another resource, of course, is to do online searching to look up the various Python commands. Now let's talk about another important piece of information, creating name selections. And you notice in my model that I have 5 or 6 already created here in the Groups tab. And these all came directly from the script. And the reason this is important is because when the model is passed over to Workbench, it's generally advisable that you make all load, boundary condition, and mesh assignments by way of name selections rather than geometric entities. And here's why. Every geometric entity from vertices to lines to faces to bodies, they all have a unique identifier to them behind the scenes. And when you scope a load to a face, the load is applied to that unique identifier for that face. In any case where the CAD changes and the identifier for that face changes, the load may become null and void. And I happen to have that exact situation right here in this script. You'll notice this first cluster of commands. These commands together delete all the components, bodies, and curves from the structure tree before anything else is executed in the script. So every time the script is run, the model is built from scratch. So there's a very high probability that a face, for example, may have a different unique identifier each time the script is run. Now do remember what I said early on when I said that it's not necessary for scripts to only be used to build models from scratch. You can use scripts to take an existing model and simply alter it. It just so happens in this case that I wanted to start from scratch each time the script was run, so I inserted these commands. Now let's move along, and I'm going to show you a quick example of how to create a name selection. It's really pretty easy. Now you may recall from earlier when I was creating script parameters that I first had to come to the Groups tab, right-click, and create parameters. That's not the case for name selections. They're created automatically directly as a result of the commands in the script. Now I typically place my commands for the name selections at the end of the script, although that's not necessary. Now let's assume this is a pressure vessel, and we need to create a name selection for the top faces so we can apply an end cap load. I'm first going to insert a comment line into my script, which will explain what the following commands will do. Create name selection of top face. I now need to insert a selection object that represents the selection of the two top faces, and we have a very convenient tool in the script editor to help us with that. But first I'm going to go out to the workspace. I'm going to left click, hold the control key, and select both top faces. I come back to the script editor and click the button to insert selection. We now have a selection object that represents the selection of those two faces. Now I'm going to define an arbitrary script variable that's assigned to that selection object. And on the following line, I can convert that script variable into a group. Notice the autocomplete that comes up and gives us the option to create a group. So I'll double click, start parentheses. Now notice the hint that shows up giving us clues about how to complete the syntax. I'll type in a string name, top face, end quote, end parentheses. Now let's rerun the script and see what happens. The script's complete. Notice in the Groups tab our name selection for top face. And all of the other name selections were created in this very same manner. Now the model's ready to pass over to Workbench for a parametric simulation. So now here we are back in Workbench, and the process from here is pretty straightforward if you've run parametric simulations before. And I'm not going to go into great details of the ins and outs of how to do that, since the focus of this video is more so on the scripting feature available in SpaceClaim. But here on our project page we notice our static structural system with the additional box below it for the parameters. We can double click and open the additional tab to look at our parameters. We immediately notice the three parameters that were created in SpaceClaim as inputs to the script. And we notice a few other additional input pressures that were created in Workbench Mechanical, which I've not opened yet. And we have at least one output parameter again from Workbench Mechanical. On the right, we can create additional design points to run various iterations. Suppose we first want to run the cylinder wall thickness at 2.5 inches and then at 2 inches. We can then come over and click this button to update all design points, and the software is going to run through the script iteratively, feeding that new CAD to Workbench Mechanical, producing the output parameters that we've requested here. I'm not going to update all design points for this video since I think you get the idea at this point. But I do want to come back to our Project tab and open Workbench Mechanical to take a peek at a few things before concluding. So I'm going to right click on Model Cell and choose Edit. It knows that we've been working in SpaceClaim and have updated data. So we're going to click Yes here and give it a minute for Workbench Mechanical to open up. So here we are looking at the CAD that represents the latest rendition of the script from SpaceClaim. And the main thing I want to point out here is our name selections that made their way over from the script to Workbench Mechanical. And notice how they've been used to create mesh assignments as well as loading conditions. Using name selections in this manner helps ensure your mesh and loading conditions stay consistent through each design point iteration. And that concludes our video discussing the scripting feature in SpaceClaim and how it can be used for parametric simulations. Thanks for watching.